MS Ramaiah University of Applied Sciences.
Hello friends, with this experiment we are determining the specific gravity of given sample of 1. Coarse aggregate, 2. Fine aggregate. Apparatus: glass vessel or jar for coarse aggregate, a wide-mouthed glass vessel such as a jar of about 1.5 liter capacity with a flat round lip and a plain ground disc of glass plate to cover it to give virtually a watertight fit. A piconometer for fine aggregate of about 1 liter capacity having a metal conical screw top with a 6 mm diameter hole at its apex. The screw top shall be watertight when it is screwed onto the jar. A balance of capacity not less than 3 kg readable and accurate to 0.5 grams. Specific gravity of a material may be defined as the ratio of weight of known volume of the material to the weight of equal volume of water, both weights being measured at same standard temperature. This standard temperature is 4 degrees Celsius. The determination of specific gravity helps in the calculation of quantities of materials required in concrete mix design. By knowing the specific gravity of each constituent in a concrete mix, its weight can be converted into solid volumes and hence a theoretical yield of concrete per unit volume can be calculated. Specific gravity is also required in calculating compaction factor in connection with workability measurements of concrete. Procedure: for coarse aggregate, the empty jar is weighed and then filled up with clean and dry coarse aggregate sample up to about 1/3 of its depth and weighed again. Now water is added to the full capacity and weighed. Care must be taken to remove air bubbles. The aggregate is removed and the jar is cleaned. It is now filled completely with water and weighed again. Fine aggregate, that is sand. The empty weight of the piconometer with conical top is taken. It is then filled up to about 1/3 of its depth with given of sand, which must be clean and dry weighed again. Water is added to this fully and weighed again. Aggregate is removed and piconometer is cleaned. Now the piconometer is filled completely with water and weighed again. Calculations and observations. Coarse aggregate. Weight of empty sample W1 in grams. Weight of vessel plus 1/3 of coarse aggregate W2 in grams. Weight of vessel plus 1/3 of coarse aggregate plus water W3 in grams. Weight of vessel plus water W4 in grams. And specific gravity is calculated by the formula shown. Fine aggregate. Weight of empty piconometer W1 in grams. Weight of piconometer plus 1/3 of fine aggregate W2 in grams. Weight of piconometer plus 1/3 of fine aggregate plus water W3 in grams. Weight of piconometer plus water W4 in grams. And specific gravity is calculated by the formula.
Hi students, now we are doing the specific gravity of fine aggregates. So what do you mean by specific gravity? It is defined as a ratio of weight of any material to the weight of equal volume of the standard material. The apparatus required for this experiment is the electronic weight balance of 1 gram accuracy, piconometer. Generally this piconometer is used to determine the specific gravity of finer material. This piconometer is having 3 parts. One is a brass conical shape along with the rubber seal, a jar and a collar cap. So the next apparatus is I have taken some quantity of sand and the water. Let's start doing the experiment. First what I am going to do is I am going to take up the empty weight of the dry pycnometer. This has to be oven dried. I am taken the empty weight of the pycnometer. This weight I am going to note it as W1 grams. After this, what I am going to do? I am going to add 1/3 layer of it with fine aggregate. Approximately 1/3 will be added. So I taken 1/3 of the sand. I am going to fix the collar and the cap back, and I am going to take up W2, that is the weight of pycnometer plus the sand particle. What I am going to do next is I am going to completely fill this with water. So we'll remove the top portion only with measuring cylinder. So first, initially what I'm going to do, I'm going to completely fill the remaining portion with water. So what I'm going to do, I'm going to add up the conical portion with the water. I'm going to make sure that this conical flask is completely filled with water. I'll remove this excess water which is outside. Okay. After filling this the tip completely with the water, I'm going to note down W4. Next, what I'm going to do, I'm going to completely throw away this W3 weight. I'm going to take up the complete empty bottle, fill it with the water, and once again I'll take the weight. After W3, what we are going to do, we are going to fill this complete container with water. Fix the collar and the cone cap. Completely fill the remaining portion with the water. Okay, take down the W4 weight. By having these 4 weights, we can easily calculate the specific gravity of the fine aggregates. Generally it lies somewhere in between 2.5 to 2.6. It depends upon the source of the fine aggregate. This completes the specific gravity of fine aggregates.
At MSR UAS, we spark your imagination unlike any other.